let's have a look at a few. So we just apply our rules. Okay, so once there's our integral, once we do that, we add 1 to the power, divide by the power. That's the same as x to the 1, so it becomes 2x to the 2 over 2. Now 4 is the same as x to the 0. So that becomes just 4x plus some constant c. We often try to tidy up if we can. X cubed on 3 plus x squared plus 4x plus c. So at this point in time, let's expand our brackets. So that's equal to the antiderivative first term cubed, which is 8x cubed plus 3 times 2x squared, which is 4x squared times 7. So let's times 7 plus 3 times 2x times 7 squared plus 7 cubed dx, which is equal to the integral of 8x cubed plus 21 times 4 is 84x squared plus 49 times 3, what's that, 147 times 2, what's that, 294x plus 7 cubed, which is 49 times 7, which is 350, 243 dx. So now 8x, add 1 to the power, which is 4 on 4, plus 84x, add 1 to the power on 3, plus 294x, add 1 to the power, plus 243x plus some constant c. Okay, the good thing is there is a nicer rule in the next exercise that helps to evaluate something like this. And obviously we can simplify expressions, but I've run out of room, so I'm going to leave it there. Something like C, again, we're going to need to expand the brackets. There is no product rule or chain rule or anything like that for us at integration. So x times x is x squared, x times 1 is x, negative 2 times x is minus 2x, negative 2 times 1 is minus 2, all with respect to x. That's equal to the integral of x squared minus x minus 2 dx. Now, notice I've still got the integral and the dx symbol. Now I start my integration, so x to the 3 on 3 minus x to the 2 on 2 minus 2x plus some constant c. Okay, so the key is to remember x itself is x to the 1, and some constant is the same as 2x to the 0, because x to the 0 is 1. All right. Come down to something like D. Shouldn't matter whether it's positive or negative. X to the minus 2 dx. Add 1 to the power, so it becomes negative 2 plus 1, divided by negative 1 plus c, which is minus 1 over x plus some constant. Okay, so whether they're negative or positive, it doesn't matter. We add to the power and divide. Let's split this one up a little bit, do the division. So that's the same as 3x squared on x squared minus x on x squared dx. Antiderivative of x squareds cancel. That's the same as 1 on x. So now add 1 to the power, which is 3x, minus, now we'll see straight away, if we add 1 to the power here, which probably shouldn't be in here, we get x to the 0 over 0, which is undefined. So in actual fact, what we will find is that the antiderivative of 1 on x is natural log x, okay? So it's worth underlining here. It's probably not a good example to be doing at this stage. We haven't quite covered that yet, all right? But just be aware that that's what the antiderivative is. Let's go on to part F. let's bring the constant out the front, 1 over. So I've got x root x to the power of minus 1 dx. 2 times, well, that's x to the 1 times x to the half, which is x to the 3 on 2, all to the power of negative 1 dx. 2 times the integral of x to the negative 3 on 2 dx. So a little bit of messing around there just to get the power of the function. So that's the same as 2. Add 1 to the power, which makes it minus a half over negative a half plus some constant. So 2 divided by negative a half is negative 4. X to the minus a half plus c, which is negative 4 over the square root of x plus some c. Okay, so just work out what the power is of the term that we've got and then work it out from there. I guess a practical application of working out the antiderivative is if we've been given the derivative function, we can now work out what the actual original function is. We've got a condition that satisfies the original function. So if I want to work out if y equals f of x, I want to find y. So I know that f dashed of x is equal to 3x squared minus x to the minus 2. So in reality, what I'm going to do here is I'm going to take an antiderivative of both sides. Because what that means is the antiderivative of f dashed of x is f of x. And that's equal to the antiderivative of 3x squared minus x to the minus 2 dx. Add 1 to the power, 3x to the 3 on 3 minus x, negative 2 plus 1, plus some constant. Let's come over here. We can say that f of x is equal to x cubed plus 1 on x plus some constant c. Although we have got an initial condition here where x is 2, y is 0. So I can say that 0 is equal to 2 cubed plus 1 on 2 plus c. Therefore, c is equal to negative 8.5, which if you like is, what's that, negative 17 on 2. So my actual function f of x is equal to, what's it equal to? X cubed plus 1 on x minus 17 on 2. Okay, have a go at a few. Okay, so you can see we've got a nice little integration rule that will help us only with integrating little linear expressions. So it's got to be 2x plus 1, 3x minus 6, minus 2x plus 4, all to some power. So instead of expanding it like we did in the previous example, we can just add 1 to the power and divide by the power, which is typical, but then we also divide by the coefficient of x, okay? So having a look at all these, we've got all of these are linear expressions, so we can apply it to those, which has got different powers, all right? So the antiderivative of this function here is, function doesn't change, 2x minus 4, add 1 to the power, which is negative 1, divide by the power, and then we also divide by the coefficient of x and plus c. So we've got negative 2 on the bottom, so that's equal to minus a half 2x minus 4 to the power of negative 1 plus some c. So we could possibly write it as negative 1 over 2 times 2x minus 4. Okay? Same thing. B, what do we have to do? It's equal to the antiderivative, 2 minus 3x, add 1 to the power, so that's to the 5 on 2, divide by the new power, but then also divide by the coefficient of x, which is negative 3. Okay, so that's what my derivative is. So let's tidy it up a bit. I'll get 2 minus 3x to the 5 on 2 over, or 5 on 2 times negative 3 is negative 15 on 2. And that's equal to, let's flip it upside down, 15 outside of 2 minus 3x to the 5 on 2 plus some c. All right, so whether or not that's like that or you put the 15 in the denominator under 2 minus 3x, it's the same thing. C, let's rewrite it initially as the power. So it's 2x minus 3 to the power of a half with respect to x equal to 2x minus 3, add 1 to the power, so it's the 3 on 2, divide by the power, which is 3 on 2, times the coefficient of x, which is 2, plus some c. So I get 2x to the minus 3, sorry, 2x minus 3 to the 3 on 2 over 3 on 2 times 2 is 6 on 2, which is just 3, which typically we might bring that 3 out the front there to the 3 on 2 plus c. Last one, again, rewrite as integral. I might bring the 2 out the front, and that gives me 2x minus 1 to the negative 2 dx, which is equal to 2 times the antiderivative, so 2x minus 1, add 1 to the power, which is negative 1, over negative 1 times coefficient of x, which is 2, plus some c. So we can see there, hopefully, that that 2 and that 2 cancel. So I'm going to have equal to negative 2x minus 1 to the negative 1, typically negative 1 over 2x minus 1 plus c. All right, so that's that nice little rule. That one, I've got to check actually. I'm pretty sure it's on our formula sheet, but it's an important little rule to remember because sometimes that's a real typical exam one sort of question. Okay.